After flying at an altitude of 1,000 meters, the hang glider starts to descend when the ground distance from that landing pad is 100 kilometers. What is the angle of depression for this part of the flight? So the flyer is 1,000 meters off the ground. Landing pad is 100 kilometers. Now that's the ground distance. So if you think about it, this would be the 100 kilometers. So we want these to be in the same units. So 1,000 meters is the same as 1 kilometer. And now we're looking for the angle of descent here. So again, instead of using 1,000 meters there, we can use 1 kilometer because 1 kilometer is 1,000 meters. So we're using opposite over adjacent, so that's tangent. So the tangent of angle x is equal to opposite, which is 1 kilometer, over the adjacent, which is 100 kilometers. Now we can use our calculator to get a decimal approximation for that. So we're wanting to find the angle whose tangent is 1 over 100. So we'll use inverse tangent. So we'll go to our calculator for a decimal approximation there. So you get approximately 0.5 degrees. Or 0.6, I guess, if we round up, 0.57. So about 0.6 degrees for your angle of depression. For the coordinates of 300 on the unit circle. Okay, so 300 will leave a reference angle of 60. So if this angle is 300, then the remaining part is 60 because a full circle is 360. And so we've got a 30, 60, 90 triangle. For the unit circle, the hypotenuse is always 1. So our short side is half of 1. And then the long leg is the short leg times root 3. So the y value here would be 1/2 times root 3, or root 3 over 2. Now if we think about what direction that would be, that's down, so it's going to be negative. And so the coordinates of that point on the unit circle would be 1/2 for the x value and negative root 3 over 2 for the y value. As you look at number 11, the standard setup here is to label the angles with capital letters and then the sides across from them with lowercase letters that match up. So capital L would be across from lowercase l, capital K across from lowercase k, and so on. So here we have enough to use the law of sines. Now when you use the law of sines, you want to fill in 3 out of the 4 parts in the proportion. So we can say the sine of L over lowercase l equals the sine of k over lowercase k. So if we fill that in, we can say the sine of 48.5 degrees over 12.6 is equal to the sine of 40.6 over lowercase k. From here, if you cross multiply, you get k times the sine of 48.5 degrees equals 12.6 times the sine of 40.6 degrees. And then we can divide both sides by the sine of 48.5 degrees. So that's the exact value for k, and then we'll go to our calculator for a decimal approximation. And so you get approximately 10.9, be 10.4, 10.948, and so on. So that rounds down to 10.9. You'll notice on this one we're missing side C, and we're told to find the measure of the missing side. And we have 2 sides and the angle across from that missing side, so we can use the law of cosines. So we'll substitute into that. So if you substitute in, you'll get that, and then square each of the 10.9 and the 23.4. Multiply the minus 2 times 10.9 times 23.4 together. And so c squared is about 240.497408. And then to get rid of square, we'll square root. Only a positive answer makes sense here. And so you get about 15.5 for the missing side. Notice that it says to round to the nearest tenth, so that's 1 decimal place. This time we're wanting to find the angle. Now the 24 feet is the goal because it says the goal is 24 feet wide. So we're trying to find the angle of the player's shot to make against the goal. So we're missing a side. We're missing an angle, and we have the 3 sides. So we're going to use the law of cosines. So this time we're missing the angle, which you could call C or X, however you want to do that. So 24 squared gives us 576. 28 squared, 784. 30 squared gives us 900. We'll combine those like terms. Now we want to get the angle by itself, or the cosine by itself. So we'll subtract 1684 from each side. And we'll divide both sides by negative 1680. Now at this point, if you want to drop the negative, you can. So the cosine of x is equal to 1108 over 1680. And then we'll do inverse cosine. So we get approximately 48.7 degrees. Here it says that Dante is standing horizontal at horizontal ground level with the base of the Empire State Building. The building's height is 1,472. The angle of elevation here is 48.4. And we're looking for his ground distance from the Empire State Building. So we can say tangent 48.4. Multiply both sides by x. Tangents will divide out, and then we'll go to our calculator for a decimal approximation. So we get approximately 1,307 feet if you round it to the nearest foot. A rocket ship is 2 miles above sea level when it begins to climb at a constant rate of 3.5 degrees for the next 40 ground miles. About how far above sea level is the rocket ship after its climb? So we want to form a right angle with this, or a right triangle I should say. Now to start with, the ship was already 2 miles above sea level. So if I find x, then what I really need to do is find x plus 2 to figure out how far above sea level the ship was. So I used the right triangle. A tangent of 3.5 degrees is equal to x over 40. Now you can multiply both sides by 40, so x is equal to 40 times the tangent of 3.5 degrees. Now again, what I'm trying to find is x plus 2. So if I call this y, then y is equal to 40 times the tangent, 3.5. And then outside of that angle, we're going to add 2. And so you get approximately 4.4 miles. If you just found x, you got 2.4. So make sure you add the 2 back to it.